Hello everyone, welcome to Augmented Technology Private Limited. Today I am excited to introduce our one of the product, that is 4DI NTC. Here we have the 4 channel digital input, 4 channel digital output and 4 channel analog input and NTC, which is communicating with the Modbus, that is RS485. Here we have the base model. In this model, here we have the power connection part. For this power connection, we have the configuration as a positive and negative. For power supply, you can provide up to 24 volt DC. For this board, here we have the RS485 for the communication. Here we have the configuration for the connection, A for the positive, B for the negative. We can connect with the Modbus cable, that is RS485 cable, with the PC to get the data. For this board, here we have the dip switch part, where user can set their own slave ID and the baud rates. For the baud rates, they are mentioned in the board already. For the slave IDs, where user can set up to 15 slave IDs. Here we have the reset button for the board. Whenever user wants to change the slave ID and the baud rate for the new configuration, on that time just need to press the reset button. Once the board will get the configuration for the new addresses. For this board, here we have the DO part, that is 4DO part, which is operated through the relay, and here we have the DI part, which is operated through the optocouplers, which supports up to 80 volt, and here we have the 4 AI channel part and also 4 NTC. In DO part, where user can connect the motors, switches and relays. For the DI, where user can connect sensors, relays, switches. And in this 4 AI channel, here we have the configuration for the switches. Okay, whenever user needs to set for the AI part, on that time all jumpers need to set in AI condition. Here in the board they have mentioned for the AI and NTC. During the AI part, just need to set the all jumpers with the AI part. Whenever need to shift for the NTC part, on that time just need to shift all jumpers with the NTC part. Like this, just simple shift the jumper with the NTC part. For the next step, we will focus on the testing process, and please concentrate on the testing procedure. Please ignore the board visuals which is provided in the video. In this video, we will only know about how to connect the power supply and how to connect the RS485 with the Modbus cable. Okay, here we have the power supply part. There we have mentioned in the board, that is positive and negative. Connect the power supply with the positive and the negative and provide the power supply. See here the LED turn on, that means power supply has provided properly. Then get to know how to connect the RS485 cable. Here we have provided the configuration as the B, that is for negative. Here I have connected the negative, A for the positive, I have connected the positive wire. So then connect this wire with the PC. Okay, this is the RS485 cable, so I am connecting this with the PC. Now we will connect the RS485 cable with the PC. So I have connected with the PC. Now open the device manager. In the device manager, go to the port here, that is showing as the COM6. That means I am using the port number 6 for the serial communication. So then go to the Modbus pole, click on connection, connect the board and select the port and click on OK. See, the board has connected properly. After proper connections, here you will get the RX and TX LED blinking continuously. That means RS485 communicating with the PC properly. In this video part, we will get to know how to configure the slave IDs and the baud rates. So here we have the slave ID and the baud rates. So by default, that is the 9600 baud rate and the slave ID will be a 1. So now we will go with the PC. See here the board has connected properly with the default baud rate and the slave IDs. So now I need to change the slave ID as the 3. Okay, before changing the slave IDs, here this is the dip switch for the slave ID. So here in the dip switch they have mentioned 1, 2, 3, 4. That means the slave ID configuration as a 1, 2, 4, 8. That means if I need the slave ID 3, then I need to hide first and the second pin. That means 1 plus 2, that will be a 3 slave IDs. Okay, then I need the baud rate as a 19200. So the first pin that is mentioned in the board, that is 19200. So I will hide this pin. Now I need to press the reset. So the board will get for the new configuration. See, here I will get the timeout error. Whenever you will get the timeout error, disconnect the board and connect the board with the new configuration. The baud rate as 19200 and the slave ID will be a 3. Okay, see, after connecting this, here the TX has continuous increasing. That means the board has connected with the new slave ID and the baud rate. So now I need to set the slave ID as the 5 and the baud rate will be a 38400. So now I will hide the first pin slave ID and the third pin slave ID. That means 4 plus 1, that will be a 5. Now I will need to set the baud rate, that is 38400. That is the second pin. So I will hide this pin and now I will press the reset. See, here I will get the timeout error. Do the same thing, disconnect the board and connect the board with the new configuration. The baud rate will be a 38400. Okay, then the slave ID will be a 5. See, here the board has connected properly with the new configurations as a slave ID 5 and the baud rate 38400. So now I need to set the baud rate as the 57600 and the slave ID will be a 15. So if I need the slave ID as the 15, then I need to hide the all slave ID pins. That will be a 15. Okay, now I need to set the baud rate, that is for the 57600. Okay, now I need to press the reset button. Here I will get the timeout error. Then disconnect the board and connect the board with the new baud rate and the slave ID. Here the baud rate 57600 and the slave ID will be a 15. See, the board has connected properly with the new slave ID and the baud rate. Now I need to set the slave ID as the same and the new baud rate, that is 15200. See, okay, 15200, that is the new baud rate. Just press the reset, disconnect the board and connect the board with the new baud rate, that is 15200. Click OK. See, the board has connected properly because I have put the slave ID 15 as same and the only change, that is baud rate. Now I need to get back all these with the default. So load the all pins. Okay, otherwise you can set only first pin as a high for the slave ID, otherwise you can low, there is no issue. Now press the reset. The board has gone for the default slave ID and the baud rate. So now here I will get the timeout error. Disconnect the board and connect the board with the default address. Baud rate is a 9600 and the slave ID will be a 1. See, the board is communicating with the properly for the default addresses. Open the Modbus and click on connection. Connect the board with the port number with the serial port. Okay, and the all baud rate and the everything will be default. Click on OK. See, here the board connected properly. Here you will get the RX and TX LED blinking with continuously. That means the RS485 communicating proper with the board. Now for the according to the datasheet, the first register will be a DO part. Okay, here we have the 4DO. The starting 4 register will be a DO part, and click on that, provide the value as the high and send the request. Within the second, the LED has turned on. That means the DO1 operated properly. And do the same thing for the DO2. Click on that and provide the value on, send the request. Here the DO2 has operated properly. Do the same thing for the DO3. Click on that and provide the value as the high. Then the DO3 operated properly. and click on the fourth DO, provide the value as the high and send the request. The DO4 has operated properly. That means the all DO is operating properly. There is no issue with the DO. Now open the Modbus, go to the connection, connect the board with the port ID and click on OK. See, the board is connected properly. That means here you are getting the RX and TX blinking continuously. That means the RS485 connected properly with the PC. And according to the datasheet, they mentioned the DI registers. Okay, on that mentioned registers you will get the DI values. For the DI we need to take the reference voltage. Here I am taking the reference voltage, that is 12 volt, which is provided in the board, that also mentioned in the DI part. And here I have taken the male to male jumper. Okay, this is the male to male jumper. For the DI reference I have connected with the 12 voltage. This is the 12 voltage reference. So whenever I will short with the DI1, here the LED also turn on for the DI1, and also in Modbus pole I will get the mentioned register value as the high. For the particular register I will get the value as the high, that is 1. I will do with the short with the DI2. See, here also you will get the LED on for the DI2, and also in Modbus for the particular register you will get the value as the 1, that is DI2. And for the DI3 I will do the same. See, here also you will get the LED on. That means in register also you will get the high value 1. For do with the DI4 also, here also the DI4 LED turn on, and also in Modbus pole you will get the value as the high 1. Don't do with the ground, only short with the DI parts except the ground part. Now open the Modbus pole and go to the connection and connect the board with the port number. Click on OK. Then go to the setup and click on read and write and select the function as a 3. Here we need a AI. For that we need a function code 3. Click on OK. See, here the board connected properly. Here also you will getting the RX and TX LED blinking continuously. That means the board is connected properly with the RS485 cable. And for the AI we need a reference as a 5 voltage, which is also we have in the board. Okay, whenever we are checking the AI, if there is a jumpers in the board, please put the all jumpers in the AI part. Okay, then I am taking the reference as the, here I have the 5 volt. Okay, and short with the positive only. Here in the board we have mentioned the polarities positive and negative. Okay, click on the short with the positive. Whenever you short with the positive, you will get the values in the particular mentioned registers. Okay, for AI1, see, there is a register mentioned in the Modbus pole. You will get the value as the 1023. That is the resolution, you will get the value. For the AI2, when I short with the 5 voltage, see, I will get the resolution value. Same for the AI3, I will get the register value as a 1023 in the mentioned registers. For the AI4 also I will do with the same. There I will get the values in the mentioned registers. According to the datasheet, check once the AI register part. Open the Modbus pole, go to the connection, connect the board with the port number and go to the setup part. Click on read and write option and select the function code, that is 3. For the NTC part we need the function code, that is 3. Click on OK. See, the board is connected properly. Here also RX and TX LED blinking continuously. That means the RS485 cable connected properly with the Modbus. Okay. Now we will check with the NTC part. If there is a jumpers mentioned in the board for the AI and NTC, on that time we need a NTC, then shift the all jumpers to the NTC part. Okay, when all jumpers are connected with the NTC part, and take the NTC sensor. Here we have the NTC sensor and take the reference for the in AI part also. See, here we have provided the NTC, so connect with the NTC sensor. See, in the mentioned registers you will get the NTC values. Okay, for the NTC one, there is the mentioned registers. See, here you will get the 298, that means 29.8, that is the temperature. Okay, and do with the same for the NTC2. In mentioned registers you will get the value for the temperature, that is getting 29 point something or 30 something, right? Do with the NTC3. Here the same, you will get the value 29.8 or 30, 29.7, you are getting the values for the temperature. Okay, do with the for the NTC4. See, in the mentioned register we will get the values. For the registers, please refer with the data sheet. You will get the particular mentioned registers for the AI, NTC and overall.